We're going to talk about rationalizing denominators of radical expressions. So to rationalize the denominator, multiply the expression by a fraction that is equal to 1. The 1 can look like whatever you need it to. So if we have, for example, a 1 could be square root of 2 over square root of 2, the square root of x over the square root of x, 3 square roots of 2 minus 4 over 3 square roots of 2 minus 4, square root of 5 plus square root of 3 over the square root of 5 plus the square root of 3, or the cube root of 2 squared over the cube root of 2 squared. So it can be, 1 can be anything, as long as it's the same thing over itself. The other thing to understand is conjugates. So it's similar to difference of squares, where remember we had a plus b times a minus b equals a squared minus b squared. So a plus b is the conjugate of a minus b. So for an example of a conjugate, 3 square roots of 2 minus 4, the conjugate of that would be 3 square roots of 2 plus 4. Square root of 5 plus the square root of 3, the conjugate of that would be square root of 5 minus the square root of 3. All right, so let's go do some examples. So for example 1, we are going to rationalize the denominator. So for part A, we have square root of 3 over the square root of 2. So I can't have a radical in my denominator, so square root of 2 is the issue. But if I multiply it by the square root of 2, that gets me square root of 2 times 2 would be the square root of 4. I create a perfect square. So what you do to the bottom of your fraction, you have to do to the top. Same thing as what you do to the denominator, you have to do to the numerator. So however you want to look at it. So on the top, we have the square root of 3 times 2 is the square root of 6. Square root of 2 times square root of 2 gets us the square root of 4. 6 is 2 times 3. It's not going to reduce down, so it'll just come on over, but the square root of 4 is 2. And that is your answer. So you're just looking to get the radical out of your denominator. All right, let's look at another one. If we have 2 over the square root of 5, we're going to multiply by the square root of 5 over itself. That's our 1. So on the top, we have 2 square roots of 5. On the bottom, we end up with square root of 5 times 5, which is 25. So we end up with 2 square roots of 5. Square root of 25 is 5, and that would be your final answer. So basically, what we're doing, because we have a square root, we need a group of 2 of the same number. So that becomes 2 5s. So we multiply by whatever it is to create that square. Here we have the square root of 1 over 37. We can't rationalize this one until we separate it. So we're going to make it square root of 1 over the square root of 37. Well, the square root of 1 is just 1. So you can take it out of the square root if you want ahead of time, or we can use it. I'm going to go ahead and do that because if this was anything but a 1, I definitely would. So we'd have 1 over that square root of 37. Now, the square root of 37 becomes our issue, so we're going to multiply by the square root of 37 over itself. So on the top, we end up with the square root of 37. On the bottom, we're going to end up with the square root of 37 squared, which is the same thing we've been doing up here, but these were smaller numbers. And so, because these were smaller numbers, we just multiplied it because we could know our square roots. I don't want to multiply 37 times 37 and then go ahead and take the square root of it. If I just write it as something squared, I can still take the square root of something squared, which takes care of each other. They cancel out. Square root of the square. So we end up with square root of 37. Square root of 37 squared, that radical takes care of the exponent, so it's just over 37. And that would be your final answer. All right, our next problem, we have square root of 49 over x. So again, we're going to split it out. Square root of 49 over the square root of x. Square root of 49 is 7 over the square root of x. Now I need to clear out that radical. on the denominator, so that's going to be multiplying by that square root of x so that they match. So 7 square roots of x over the square root of x squared. Again, the radical takes care of the square, and you end up with 7 square roots of x over x. All right, our next problem, we have 12 over the cubed root of 10. Now this one's a little bit different because we have to have the cubed root. So we need to have 3 10s to clear that out. We only have 1, and we need 3 because of the cubed. In the past, we needed 2 of them so that we can take the square root. But you've got to have 3 if you want to do the cubed root. So we are going to multiply by the cubed root of 10 squared. And I'm writing it in this format so that you can see we have 1 plus 2 would get us 3 of those 10s, and we need to take the cubed root of something that is a cube. So on the top, we have 12 cubed root. I can go ahead and multiply that. 10 squared is going to get us 100. On the bottom, I have the cubed root. 10 times 10 squared will get us 10 cubed, which is also 1,000, but we really are caring about getting something that's cubed so that the cubed root of something cubed will just get us what's inside. So now we have 12 cubed root of 100 over 10. Now between 12 and 10, it will reduce by 2, so we end up with 6 cubed root of 100 over 5. Our next example, we have 11 over the square root of 8x. To move forward on this, we need to reduce this down because I don't want to multiply just by 8x. You could, but we can actually simplify this. So 8 would be 2 times 4. 4 is 2 times 2. So 11 over the square root, 2 times 2 times 2, x. So I can take a group of 2 2's out. So we end up with 11 over 2 square root of 2x. So I do this so that you can understand you really only have to clear out what you wouldn't clear out before. So we're just going to multiply by our square root of 2x over the square root of 2x. So on the top, we end up with 11 square root of 2x. And on the bottom, we end up with 2 square root of 2 times 2 is 4. X times x is x squared. You could also write this as 2x squared inside that radical. You could do it either this way or this way. It doesn't matter. So we have 11 square root of 2x over square root of 4 is 2. So we'd have 2 times 2. Square root of x squared would be x. Or you could have canceled this way and had 2x. Either way, you end up multiplying by 2x. So this ends up 11 square root of 2x over 4x. And that would be your final answer. All right, let's go look at another example. We have 5 over the square root of 3 plus 2. This is where we have 2 terms in our denominator, so we're going to have to do the multiply by a conjugate. So it'll look just like this, except we'll change the sign in the middle. So square root of 3 minus 2, square root of 3 minus 2. So on the top now we have 5 times the square root of 3 minus 2, and on the bottom we have the square root of 3 plus 2 times the square root of 3 minus 2. This is where we end up, this is the difference of squares part on the bottom. So on the top, I'm going to leave the top the way it is. So 5 times square root of 3 minus 2, and I'm going to focus on our denominator. So square root of 3 times square root of 3 gets us the square root of 9. Square root of 3 times a negative 2 minus 2 square roots of 3. 2 times square root of 3 would be plus 2 square roots of 3, and 2 times negative 2 is minus 4. Now what you'll notice is that those two middle terms should cancel. So now we have 5 times our square root of 3 minus 2. We have the square root of 9, which is 3. The two middle terms canceled, minus 4. Well, that ends up being 5 times square root of 3 minus 2 over negative 1. We can bring the negative up and get negative 5 times square root of 3 minus 2. Now, depending on your homework and what they're looking for in an answer, you can either leave it like that, or you could then distribute this to be negative 5 square root of 3. Negative 5 times negative 2 would be positive 10. So depending on what they're looking for in the homework. So I would be good with this answer, but the homework may want it in that format. So you can always view an example and see what they're looking for. All right, so this was our part A. Let's go look at part B. So for part B, we have 8 over 3 minus the square root of 13. So again, we're going to have to multiply by the conjugate, which will be 3 plus that square root of 13 over itself. So now we have 8 times 3 plus the square root of 13 over 3 minus the square root of 13 times 3 plus the square root of 13. So on the top, we have 8 times 3 plus that square root of 13. Down here, we'll have 3 times 3 will get us 9. 3 times the square root of 13 minus the square root of 13 times 3 is minus 3 times that square root of 13. And negative times the positive will get us negative. Square root of 13 times the square root of 13. It is the square root of 169, or you could write it as 13 squared. Either way works. So 8 times 3 plus the square root of 13. On the bottom, we have our term here that will combine together. So we have 9 for our first term. Square root of 169 will get us 13, so minus 13. So 8 times 3 plus the square root of 13, and 9 minus 13 will get us negative 4. So you may have wondered in the past why I do not multiply these out yet. I do that because sometimes our numerator will reduce with our denominator, and if we multiply out the 8, or if up here we had multiplied out the 5, it didn't reduce with the 5, but if it will, we have to go back and reduce it. So I always leave the top until I find out what our denominator is. All right, so 8 divided by negative 4, so negative 4 will go into our 8 and leave us with a negative 2. So we end up with negative 2 times 3 plus that square root of 13, which if we multiplied that out, we would get negative 2 times 3 would be negative 6 minus 2 square roots of 13. So depending, again, how they want your answer in your homework, you'll either distribute it or not. All right, so we have one more problem. So we have the square root of 10 minus the square root of 11 over the square root of 10 plus the square root of 11. So basically, we have a conjugate situation happening here on top of each other, but we're going to still have to clear out our denominator on the bottom. So square root of 10 minus square root of 11. So on the top, we have the square root of 10 minus that square root of 11 times the square root of 10 minus the square root of 11. And on the bottom, we have the square root of 10 plus the square root of 11 times the square root of 10 minus the square root of 11. This time we're actually going to FOIL the top. We will FOIL it out. So square root of 10 times square root of 10 will get us the square root of 100. Square root of 10 times negative square root of 11 will get us the square root of 110. Square root of 11 times the square root of 10 will get us minus that square root of 110 again. And negative square root of 11 times negative square root of 11 will get us plus the square root of 121. All over the denominator, square root of 10 times square root of 10 will get us 100. Square root of 10 times negative square root of 11 will be minus the square root of 110. Square root of 11 times square root of 11 will be plus that square root of 110. And square root of 11 times negative square root of 11 will be minus the square root of 121. All right, so on the top we have 10. We have minus the square root of 10 minus the square root of 10 gets us minus 2 square roots of 110. Square root of 121 is 11. All over. These two terms will cancel because the bottom became that difference of squares. Square root of 100 will get us 10 minus the square root of 121, which is 11. So on the top we have 10 plus 11, which is 21, minus 2 square roots of 110. And then 10 minus 11 would be a negative 1. So this will become negative 1 because you can divide or multiply by it. So a negative there, we've got to bring it up as 21 minus 2 square roots of 110. And we'll go ahead and distribute that out. So negative 21 plus 2 square roots of 110. So with that, whenever you're dividing by a negative 1, you can just bring that up like that because it's the same process. It's you just bringing up that negative sign. Just like we did previously with the negative 1 here, and we brought it up. And that would be your final answer.